Hello class, this video is meant to help you with the integration technique that we learned today, which was integration by substitution. So I'm actually going to do a problem from your homework assignment, problem number 24, which is I think the toughest one I assigned, but it's the indefinite integral of x cubed divided by the square root of 1 plus x to the fourth dx. It's a little sloppy, but okay. It's an indefinite integral, remember, because there's no bounds on it, no upper and lower bounds. So it's really just finding an antiderivative. But the problem is our integrand, the function we're integrating, is pretty complicated looking. But we can think of it as a composite function. We can think of it as composed of simpler functions. And this is where the u substitution comes in. I'm going to look at this 1 plus x to the fourth as sort of an inner function that I'm going to call u. So my u here will be 1 plus x to the fourth. Okay? And so I'm going to rewrite everything, but replacing 1 plus x to the fourth with my new name for it, which is u. So the indefinite integral of x cubed over the square root of u dx. So that's all I did was just call this thing 1 plus x to the fourth. I called it u, and then I replaced it with u. It's a new name. Okay. But now I can't integrate yet because I've got this dx and this x cubed here. So my variables don't match up. I've got some u's and some x's. So what I need to do is, first order of business is to get rid of this dx. I need to make that a du. And I can't just make it a du. I've got to replace dx with what it is in terms of du. So I go to this equation here, which tells me what u is in terms of x, and I'm going to get it to tell me what du is in terms of dx. So I'm going to do that by differentiating this with respect to x. So I'm going to find du dx. That's a simple differentiation. Even though we're working in integration, we can't forget differentiation. So du dx is 4x cubed. And I want to replace the dx, so I've got to solve this for dx. And so if you do some simple algebra here, you can see that dx is equal to du over 4x cubed. Okay, so I'm going to take that and I'm going to put it where my dx is here. So I'm going to, again, just rewrite it by, and the only thing that's different is this dx is going to be replaced with what it is in terms of du. So I've got x cubed over square root of u times du over 4x cubed. So now I've got the du there. It's still a little, okay, well, I think I have enough power. It's still a little disconcerting that there's the x in here with it, but if you notice, it cancels. And all the ones I gave you for homework are going to work out nice like that, where it's going to cancel. Tomorrow, they're not all going to work out like that, but I'll tell you how to deal with that. And I'm actually going to write this as 1/4. That's from the 4 in the denominator, and then u to the negative 1/2. The 1/2 is from the square root. The negative is because it was in a denominator, and then du. And now I'm ready to actually integrate. This looks pretty nice. This is pretty easy to do. So I've got 1/4. It's just a constant I can pull out, and then the antiderivative of u to the negative 1/2. Well, negative 1/2 plus 1 is 1/2, So it's 1 over a half times u to the 1/2 plus c, right? And then this is because 4 times a half is 2, so it's 1 over 2, right? Yes, it's 1 over 2, or just a half. U to the 1/2, you can check that algebra on your own. 1/2 u to the 1/2 plus c. But now I can't leave it in terms of u, remember. I've got to replace that with what it is in terms of x. So I've got 1/2, and then I go back up here with my 1 plus x to the 4th. That's what u actually is. 1 plus x to the 4th to the 1/2. And you can write that as a square root if you want, plus c. There you go. And if you differentiate this, since this is the antiderivative, if you differentiate it, you should get back the integrand. And you can check that out on your own if you want. All right, thanks a lot. I hope that helped.